Good. Good. Ma'am?
Yes, shall we start?
Yes, ma'am. Before which we are having an official way, or a simple introduction about you.
Yeah, okay, please.
Yes, ma'am. Good morning, all. Today we are on the fourth day of 5-day national level online workshop on research with patenting. The research person for today's session is Dr. A.N. Sigapai, Professor, Department of Computer Science and Engineering, Annamalai University. Her topic for today's session is Data Analysis and Research. Dr. Sigapai received her bachelor's degree in computer science and engineering from Annamalai University in year 1993 and her master's degree in the same discipline from Anna University in 2001. She had her doctoral degree from Annamalai University in 2013. She started her career as lecturer in computer science and engineering in Annamalai University in 1995. She had authored more than 25 research publications in international journal and more than 25 articles in international and national, presented her articles in international and national conferences. She was a recipient of Best Paper Award in National System Conference in 2012 held by System Society of India. She has organized several international and national conferences and workshops and had delivered more than 30 special lectures in faculty development program. She had served as Assistant Director at All India Council for Technical Education, New Delhi for 2 years. Dr. Sigapai played a key role in implementation of rupees 1.40 crore worth Obama Singh 21st Century Knowledge Initiative (OSI) award bestowed on Annamalai University. Under this auspicious award, she had been the Tennis Technological University USA exchange visitor during January-February 2014 and delivered lectures for international graduate students. Her varied interests and skills earned her place in Rotary International sponsored sponsored Group Study Exchange GSE team that visited Arizona, USA during May-June 2006. Her research interests include image, speech processing, machine learning, and data science. Ma'am, we are happy to have you as a resource person for this session. Now the session is yours, ma'am.
Thanks, Deepa. Thanks for the introduction. Good morning, audience. Before I begin my session, I would like to thank Madam Deepa and the authorities of Ramakrishna College of Arts and Science for giving me this opportunity to deliver a lecture in your workshop. And I will take you to the presentation. Yes, is the presentation visible?
Yes, ma'am.
Okay. So yeah, as Deepa said, I'm here to deliver a lecture on data analysis in research. Today we all know that we are flooded with data, and whether we carry out research in a formal manner or not, every day we keep looking at data. We gain access to data, and we are forced to analyze the data so that we can take some decisions. So if you look at this, you will understand, how the scenario has changed in processing data. In the past, typically what we have been doing is we have been taking decisions based on our experience, the past experience, and in earlier days, there was not much availability of data. Access to data was always a challenge in the olden days. Whereas now, if you look at the scenario, it's not like that. Every day, millions of terabytes of data is being generated. All around us, we see a lot of data in various formats, and we have plenty of access to data. The more and more we have access to data, the less and less we need to have a personal experience on taking some decisions. Instead, just by analyzing the data using some tools, we can easily make decisions. So that's what I'm trying to say here. So the very reason that so much of data is available and data is going to help us in making decisions, that's the whole reason behind the understanding that we should gain on data analysis. How to analyze data so that we can make good decisions. If you look at today's scenario, for example, what you see in this slide is when you talk of data, data is raw. It's just numeric data or textual data or image data. It's just raw data. By raw data, what I'm meaning is it is unprocessed. When it is unprocessed, if it is numeric data, it will be some numbers like what you see there, 192.234, some IP address, and some textual data, some image data. All this you get. This is all raw data. This raw data, after it gets processed, that's what we call it as information. So data as such, when we get it, it is just raw. After processing, you try to coin some meaning to the data. That is what is called information. The moment you have information, that is processed data you have, it will help you in deciding what you want to do based on all the available data. What is that you want to do based on the context? You will try to take a decision. So finally, the end of the whole process is when you want to decide something. For instance, let us take a very simple example. Now, before you start your day, either to go to work or to go to college for studies or for any other purpose, when you are about to step out of your house, the first thing you decide is about your dress, what attire to wear. How do you decide that? You try to process a lot of data in your brain, and you try to pick your clothes for wearing for a particular day, for a particular situation. What is that data? Typically, for example, if you consider the data, it will be like, is it raining outside today, or is it a hot summer day? And where is that I'm going to? Am I going to workplace, or am I going to study, or am I going to attend a function? And the moment you decide the moment you have details on what is that you're going to do today, work or study or attend a function, then you will decide whether it's an important function. If it is to a classroom, should I wear a semi-formal dress or a formal dress? Am I going to give a lecture, or am I just going to attend a lecture? So like this, you have a lot of data. All this is unprocessed raw data. Now you pick all this data, process it, and then you apply your contextual knowledge, and finally you take a decision. Okay, it is a rainy day, I am going to attend a lecture, and I will just be a participant, and I will be attending it on campus. So I will pick up a dress which will suit this rainy season, and as well which will be a semi-formal one or something like that. So that is what is the final decision making. So from raw data we start, and it leads all the way up to decision making. So in this process, what our brain does is, the human brain does is, it does analyze the data. There's a whole lot of data. You have numeric data, you have textual data, you have image data, audio data. Like this, in real world scenario, you have plenty of data in plenty of different formats. Typically, the human brain easily does this analysis. But when it comes to using a computer for doing all this work, you need to go for some statistical concepts, and you need to coin what are called as algorithms and do the work. All this whole thing is involved, whether you take up academic research or industrial research or any other kind of marketing research or whatever it is. The whole process is centered around what is called as data analysis. So basically, if you try to understand where this data analysis lies in the research scenario, when you're taking up any research, where at what stage does this data analysis activity come into picture? So typically, you start with your research design. Basically, probably in your previous sessions, you might have had an introduction to what are the various types of research and research designs that are available. So irrespective of whether you take up experimental or descriptive or explorative, whatever kind of research design you choose, subsequently you need to go for a research method, selection of your research method, and then you go for collecting literature review, and based on the existing literature, you will try to identify or try to narrow down to what research questions you will address in your research. Basically, with all these three stages, initially when you start your research work, you will have just a very broad idea with respect to your research area. Then from there, you will have to confine yourself to a research problem, and you have to come up with what are called as research questions. Research question is very, very important when you're doing your research, because you are trying to do a research in order to find answer for something, for the study that you're taking up, the research study work that you're taking up, through which you are trying to answer some questions which are not yet answered, or which are answered for which you want to augment it, and so on. So in that case, you have to formulate your research questions. And to refine your research questions, you can collect a lot of literature, you can study the literature, and you can formulate your research questions. Once you formulate your research question, then you will form what is called the research hypothesis. Having done all this, then you will start going around and you will collect data to carry out your research, because you can test your hypothesis, research hypothesis, only through experiments. When you want to conduct experiments, you must have data. So whether it is a scientific research, a physical sciences based research, or a biological sciences research activity, or it is a social sciences research, or any field for that matter, even if it is marketing research, whatever it is, you need to collect data. So you conduct a lot of experiments. When it is physical sciences, you conduct experiments and you get your data. Whereas when it is in other fields, like in marketing research, you will collect data and you will analyze the data. So all the whole thing you will do is, at this stage of data collection, you will collect a lot of data which is relevant, so that you can conduct your research experiments. Now, once data collection is over, then comes the most important activity, which is called data analysis. You must choose proper data analysis methods, and you have to conduct your research. Once data analysis is over, you will have the results. Once you have the results in hand, you will have to make it, present it to your audience in a manner which everybody can understand, and which will be able to justify the research hypothesis you started. So this is the whole research scenario. So starting from the choice of research design, to the research method selection, on to literature review and collecting data, and finally you end up with analyzing your data and then presenting your results. So now this lecture that I'm giving you on data analysis is the last but one stage. So going forward, what exactly is data analysis and why is it important? A lot of researchers have given nice definitions based on their interpretations, based on the existing literature they had access to. They have coined nice definitions. Particularly one interesting definition given by Hitchcock and Hughes, that states that data analysis deals with the ways in which the researcher moves from a description of what is the case to an explanation of why what is the case is the case. This is a very interesting definition that you see. Basically, when you start your research problem, you know what you're trying to solve, what problem you're trying to solve, what research question you're trying to address. But why, how, and so on, all these things come into picture only when you do this data analysis. So basically, the question of what is from where you start your research. From there you dig further, you collect data and you start analyzing the data. Then that is where you will be able to either accept the research hypothesis or reject the hypothesis that you have coined at the start of your research. So basically, if you have to define data analysis in layman terms, you can just understand it as a simple process, which is very systematic. You do something in step 1, step 2, and so on. So it's a systematic process of utilizing the data. So as you know, for data analysis, as we have seen in the last slide, it takes its input from the data collection activity. So the data that you have collected, that is the input for data analysis. And this is a systematic process wherein you handle your data so that you can answer the research questions that you coined at the start of your research through the application of statistical and logical techniques. So this is what is a layman understanding of what data analysis is. So through data analysis, what is that we are going to achieve? The aim of data analysis is to distinguish between an event occurring as either reflecting a true effect versus a false one. So what is this? As we go through the examples in the coming slides, you will understand this aim. And why is that we go for data analysis? Why do we need data analysis? Basically, you collect a lot of data, but just as I said, data is just raw in nature. It is unprocessed. And in order to make some meaningful information, extract some meaningful information out of it, you have to analyze your data. Only then you can understand what that data is about. And after doing data analysis only, you will come up with some presentations in the form of charts and graphs and so on. From where you will be able to make the meaning from that data. So that's what we mean by making sense of data. So you have to make out some useful, meaningful information from that data, for which you have to necessarily conduct data analysis. Basically, when you carry out research, you will do a lot of data collection and you will also do analysis. All this work you are doing in order to test the research hypothesis that you coined at the start of your research. As I said, you start with your research questions and you formulate your research hypothesis. So in order to either accept or reject the hypothesis, you conduct a lot of experiments where you analyze your research data. So that is where you need this data analysis. And if you don't do a proper data analysis, then whatever conclusions you arrive at, that will not be accepted by other peer researchers. So in order for the scientific research community to accept your conclusions, you need to support your research experiments with proper analysis and presentation of those results. So for all these reasons, you need to perform data analysis. And what are the goals of data analysis? From the data which you have collected, you should be able to obtain usable and useful information. See, these terms are very important, usable and useful. So basically, before you start data analysis, you have unprocessed raw data. So after processing, the output will be usable and useful information. That's the main aim of data analysis. And also you would like to understand what are the patterns available in the data. So if you collect a lot of data, depending on the kind of research problem you have chosen, you may have to collect data from 1,000 subjects or 10,000 subjects or more, or from different sources you may have to collect data and so on. Once you collect all that data, when it's all just raw data, just looking at some numbers and text, you can't make out what it is. The moment you start applying data analysis methods, you can identify and understand the patterns that are present in the data. And when we say data collection, we would have collected data with some variables. You basically in research, you will have what are called as dependent variables and independent variables. You would have listed the various dependent and independent variables pertaining to your research. And there will be some kind of relationship among the variables which you will try to understand only when you carry out the data analysis. Before you start the data analysis, you will only tentatively assume that there will be this kind of a relationship between this variable and that variable. But to make sure that it is there, you need to do data analysis and you need to confirm what is the kind of relationship that exists between the variables. And you can compare your variables and identify the similarities and differences between variables, the relationship, etc. And you can also explain the cause and effect phenomena. When you do something, what is the effect? What variable gets affected? when you modify certain variables or when certain variables take certain kinds of values, what is the effect? Which other variables are affected? This is what we'll call as the cause and effect phenomena. To understand this is a very important aspect of research. To understand and explain the cause and effect phenomena, we need to perform data analysis. And in order to predict the outcome of your research, we need to do data analysis. So these are some of the reasons and goals of data analysis. And before you do your data analysis, the previous prior stages that you have to go through are three important phases. One is data validation, the other is data editing and data coding. All this you must have completed soon after you finish your data collection work. Once you decide on your research problem, you formulate your research questions and you complete your data collection, then with the whole lot of raw data available collected from different sources, from different subjects, you have a whole lot of volume of data in your hand. But then that data as such, if you try to process it using data analysis methods, you may or may not get correct results, because many a times data will have some errors, something like you will have missing data or duplicate data or something. So because of all these reasons, you need to first perform what is called as data validation. So as per some preset standards, you need to understand what data you have collected. Is it all okay as per the preset standards? Is there any bias? Have we collected unbiased data samples? All this you have to ensure. This activity is what is called as data validation. Once you have validated your data, the next thing is you go about doing what is called as data editing. What is data editing? Why do we do it? So we do this in order to confirm that the data is free of errors. What errors? What are the possible errors? Sometimes there will be some erroneous data. So through, by going through the data manually, sometimes you will be able to find out those things. So you can find out and correct those mistakes. If you don't correct those mistakes, if you don't do the data editing, it will have an impact during data analysis and it might lead to wrong answers finally. So to solve those problems, it's better you do data editing. Typically, for example, some simple checks like outlier checks. Those values which are totally out of the scenario, those kind of things you can check and you can try to either collect the data once again, or you can try to do some interpolation or extrapolation or something, or you can even omit that data and go for a fresh data collection or something like that. So you have to complete this data editing activity. Subsequently, after data editing is over, then you go for data coding, because not always we get the exact numeric data that we want. So that it will be easy for us to process during data analysis. Many times we will get textual data, or we'll get some numeric data itself in forms which are not very easy to understand in data analysis. So for that, we will do data coding. This actually involves grouping and assigning values to the survey responses. Basically, most of the research will deal with conducting some kind of surveys and collecting data. It could be either a field survey, or it could be an online survey, or anything. Whatever be the case, the data that you have collected, when it's not in a format which can be easily taken up for data analysis, then you go for this data coding, where you will do grouping and assigning values such that it will be easy for us to process the data. So irrespective of the kind of research that you do, you need to prepare your data such that you can do data analysis. So the stages involved in this activity are data validation, data editing, and data coding. All this, in short, if you have to call it, it's all just pre-processing. That's all. The moment you have your data collected from the field, based on surveys or based on experiments or something, you have to validate your data, edit the data, and do some kind of coding, so that the work of data analysis will be done in a much nice manner. Before we go into the exact data analysis portion, since we are going to deal with data, we must know what are the types of data available. So basically, there are two broad categories of data, one depending on the two kinds of research, qualitative and quantitative research. With that perspective, we will classify data into two categories as qualitative data and quantitative data. What is qualitative data? Qualitative data or qualitative research will deal with textual descriptions, diagrams, images, maps, and so on. So all that which is not necessarily numeric will all fit into this category called qualitative. Coming to quantitative research deals with more of numeric data. The whole lot of numbers when you do a field work and you collect data, or you give us a survey form and some people fill up the form and all those will be quantitative numbers. So basically data falls into one of these two categories, either qualitative or quantitative, depending on the kind of research that you're doing. So if it's qualitative research, most of your data will be qualitative in nature. And when it comes to experimental research, which give you some kind of numbers, it will come under this category of quantitative. And in quantitative, again, you have two categories, one called categorical and the other called numerical data. Categorical, from the name itself, you understand data will be in the form of categories. And numerical data, it's just quantitative data in the form of numbers. So in categorical data, we have nominal and ordinal categories. And in numerical, we have discrete, whole numbers, and you have continuous values. So these are the types of data. And more specifically, when it comes to types of data, the actual values that you're collecting for your dependent and independent variables will be one of these four types: nominal, ordinal, interval, or ratio data. So nominal data and ordinal data both got to do something with categories. And in categories, when there is no ordering, then that is what you will call it as nominal data. Typical examples for nominal data are marital status, whether a person is married or not. So the categories are married people, unmarried people. And similarly, gender, male, female. Then type of car owned. For example, you have sedan cars, that's one category, and you have hatchback cars, that's another category. So these are all categories, but wherein you don't have any kind of ordering or ranking. That type of data is what is called as nominal data. So you need not necessarily have two categories. You can even have more categories. But typically, most nominal data will have two categories. Sometimes there might be more categories. But the point to be understood is in nominal data, you won't have any ordering. Specific ordering will not be there. Coming to ordinal data, in ordinal, from the name itself, you understand, you will have some ordering. Ordering meaning ranking. What is this ranking or ordering? Typical examples you see is in your university exam. When you appear for university exam, if it's a grading system that is followed in your university, you will typically have letter grades like S grade, A grade, B grade, and so on. So there is an ordering. S means the topmost grade, A means the next one, B is the next one, and so on. You have a particular ordering. So here again, you have grouping of data, but then the ordering is done for the various categories. That kind of data is called ordinal data. Typically, when you give a star rating, when you buy products and you give star rating for the products, you give a single star, double star, triple star, and so on. So you have 1 star, meaning that's one level, one rank. Then you have 2 stars, that is second rank, and so on, like this it goes. So this is ordinal data. So both ordinal data and nominal data deal with categories, wherein in nominal data, you will not have any ordering, whereas in ordinal data, you will have an ordering. So like first rank, second rank, third rank, and so on. Then comes the other numeric data. When it comes to numeric data, you have interval data and ratio data. These are again very similar with a subtle difference. Interval data will have values. Basically, whatever you measure, those measurement values, you can put it in the form of interval data, wherein there is no true zero. That's what is called as interval data. Typical example for this is the temperature that you measure. All this is measurement data. In interval data, whatever we measure from experiments, those things you can put it as interval data. But the point to be remembered here is there's no true zero. For example, temperatures that you measure in a Fahrenheit or Celsius, all this is called interval data. And what is ratio data? The differences that you make between measurements, wherein a true zero exists, that is what is called as a ratio data. Here again, things that you measure like height, weight, etc. These are all examples for a ratio data. So typically there is a true zero here. For example, a zero means it's just none. That's what it means here. So these are the 4 types of data which we will be dealing with. Right. an idea of all this is required when you want to analyze your data. Only when you know what is the nature of your data, whether it is nominal data or ordinal, etc. Based on that only you can carry out the analysis. That's the reason why we saw this. Now, when you want to do data analysis, now that you have a knowledge of what is the prerequisite, the prior stages before you do data analysis, what prior things you should do, what are the types of data available, now we can do the data analysis. Coming to data analysis, depending on whether you're conducting qualitative research or quantitative research, the methods are different. So if you want to pursue qualitative research, typically qualitative research is carried out by social science researchers. Typically, people in social sciences field, the kind of data that they'll be collecting will be based on discussions with people in the field. So the data that you collect will be either in the form of audio, or sometimes it will be video, or sometimes it will be text and so on. This kind of data is what is called as qualitative research data. So typically in social sciences field, you will have a lot of qualitative research data, which comprises of textual words, descriptions, detailed descriptions, images, sometimes even symbols, sometimes audio, video, etc. All this will come under the category of qualitative research. What are the methods available for doing data analysis in qualitative research? There are 4 methods: content analysis, narrative analysis, discourse analysis, and grounded theory. These are the 4 methods you have for data analysis in qualitative research. If you take a look at what content analysis, briefly to say that it is to analyze the documented information from the text data, or from the images, or from video or something. You have to analyze the content. Basically, depending on the kind of research questions that you will have, you will carry out the content analysis. Typically, it is done in order to analyze the responses from the candidates who are being interviewed. So this is analyzing the content, which could either be in the form of text, or it could be in the form of audio, or it could be in the form of symbols and so on. This approach is what is called as content analysis. The next method you have is narrative analysis, where we try to gather information from various sources like personal interviews, field observations, surveys, and so on. Here we'll try to understand or do analysis based on the narrations. Narrations meaning the opinion that is shared by the people. We are trying to analyze this narration given by the users, by the people, in order to find out the answers for the research questions. So all the research that we are carrying out is mainly to find answers for the research questions. So here in narrative analysis, we will try to discuss with the persons involved, and we'll try to understand what stories and opinions they are trying to explain to us. And the next method that we have is discourse analysis, wherein we will try to take the social context under which the person or the respondent is giving us the answers, that also into consideration. That is what is called as discourse analysis, where we will mainly focus on the interactions with people. This is largely verbal, and you will record this verbal interaction with people, and from that you will try to analyze it. Mainly this kind of data analysis method focuses on the lifestyle and the day-to-day environment wherein the respondent is giving us answers before drawing any conclusions, right? All this has to be taken into account, not just the answers, but the context in which the answers have been given, the responses have been given, the lifestyle and the day-to-day environment in which they have given it. This kind of analysis method is called discourse analysis. The next one we have is grounded theory, where we will try to explain why a particular phenomenon has happened. Generally, we will be conducting the experiment in different settings, and we will try to collect data, and we will try to study that data. This approach is what is called as grounded theory, where we will try to draw some explanations for why a particular thing has happened. So this is more iterative in nature. Repeatedly, you will carry out the work and in different settings, and you will try to make out the reason why a particular phenomenon has happened. So these are the 4 kinds of data analysis methods which are pursued in qualitative research: content analysis, narrative analysis, discourse, and grounded theory. Right? Now, from here, we move forward to quantitative research, which is what most of us do. Most academicians and most people who are doing research in marketing field, etc., we pursue this kind of research, quantitative research. From the name itself, you understand quantitative, meaning numbers, numerics. So you have got a lot to deal with, a lot of numbers. So here comes the maths and statistics part, where the data that we collect is mostly numbers. So then you have to take the help of statistics in order to answer your research questions. So here, the methods for doing out data analysis in quantitative research broadly falls under two categories. One, descriptive statistics, the other, inferential statistics. What is descriptive? From the name itself, you understand you are trying to describe your data through statistics. That is what is called descriptive statistics. So you have collected data, you have done validation, coding, editing, everything is done. Now you have the data in hand. Now you will apply some statistical equations and you will try to describe the data. In other words, you are trying to understand the patterns present in the data, you are trying to understand the relationship among the variables and so on. So this is what is called descriptive statistics. Typically, when you're dealing with only one variable, you will call that kind of analysis as univariate analysis, where a single variable is alone taken into consideration for analysis. Many research problems, you will not just deal with univariate, you will have more variables. So you will have bivariate and so on. You will have two variables, you will have more multivariate, multiple variables and so on. But the most fundamental thing which is easy for us to understand and to get started is univariate analysis, where we will be dealing with just a single variable. And typically in descriptive statistics, we will keep the research or outcome limited to the sample that we have collected. So when you conduct an experiment, how many trials you have done and how much data you have collected, that is what we will call it as the sample. So the research outcome that you get, that will be limited only to the sample. We will not generalize it for a large population. So this is the crux of descriptive statistics. Coming to the other end of the spectrum, we have inferential statistics, where this is done to showcase the relationship between different variables. More particularly, when you have multiple variables, some n number of variables you have, and you want to compare your data, you want to analyze the relationship between the variables and so on, and that too for a larger population. That is where you will go for a inferential statistics approach. So if you look at descriptive statistics, there, as I said, you will concentrate on the small sample, the limited sample that you had access to, from which you have collected data, and that you are subjecting it to some statistical analysis. Whereas in inferential statistics, from the small sample collected, you will try to extend it to a larger population so that you can generalize it. So descriptive statistics was more specific to a small sample, whereas inferential statistics is something where we will try to extend it to a larger population. So we can try to predict some outcome about a larger population after you conduct the research. So this is about inferential statistics. So we will get into each of these and the techniques in this. In descriptive statistics, how do we conduct research? There are four methods here. We have measures of frequency, measures of central tendency, measures of dispersion or variation, and measures of shape. Now, all of this is not something new to us. Right from our school days, we have been studying. We have been studying it from the point of view of a maths class or a statistics class, which is exactly what we will fit into research here. When it comes to advanced stages of research also, these basic math and statistics techniques is what will help us in doing the data analysis. So in descriptive statistics, we have four categories. We have four methods. Measures of frequency. From the name itself, you understand frequency, meaning that it has got something to do with the count or the number of times. The moment we say frequency, it is just the number of times something occurs. So a particular thing, how many times it occurs, an event, how many times it occurs, a particular value, how many times it occurs. Just count that. That is what is called measures of frequency. Typical measures that you have here are just the count, the number of items, that is count. And when you express it in terms of percentages, that is again a measure. Then the frequency, again, that is the number of times, representing the number of times something occurs. And typically this measure is used to denote how often a particular event occurs. Then the second category is measures of central tendency, where we will deal with mean, median, and mode. And this is mainly done to showcase the most common or average response. Then measures of dispersion or variation, this will help us in understanding how spread out our data is. Then measures of shape will tell us something about the symmetry and heaviness of the distribution of data. Each of this we will go in detail. First, frequency distribution. A simple example I have chosen here. Let us take a small data set of some children in the age group of 1 to 6 years. So in our data set, we have totally 26 children. Some of them are 1 year old, some of them are 2 years old, and so on. So this, if you want to represent it in the form of a small table like this, frequency distribution table. So after collecting your data, you can put a table wherein you have the age groups 1, 2, 3, 4, 5, 6, because our data set has got children from age 1 up to age 6. So we have 6 categories here, and for each category we are counting how many children are in that particular age. In age 1 there are 5 children. In age 2 there are 3 children. So this is what is frequency. In other words, we are counting how many children are in age 1. So frequency is just count or the number of times the particular variable occurs. So this is called as a measure of frequency distribution. Then this thing that we have done here, this is for each age in the entire study period, 1 to 6 years. This again, we can group it into small categories. So we group ages 1 to 2 as one category, ages 3 to 4 as another category, and 5 to 6 as another. So in 1 to 2, if you see how many children are there, so it is just count all children who are in age 1 and age 2 and group it and put it in one category. So 5 plus 3, totally 8. Similarly, ages 3 to 4, 7 plus 5, 12. And ages 5 to 6, it's 4 plus 6. 4 plus 2, it is 6. So this way you can also have a group frequency. So grouping the ages into categories, and you're forming the frequency distribution. So from this, what we understand is just about how many times something occurs. And coming to the next measure, if you go back to this, first we have studied what is measures of frequency. Then next one is measures of central tendency. So for central tendency, when you collect a lot of data, say 1,000 or 10,000 samples you have collected, that data you want to analyze, typically you would like to find out what is the center value. For finding the center value, you can either use mean or you can use the median. What is mean? Mean is just the average. So you have n samples, x1, x2, etc. up to n, xn, n samples. So you just add all of them and divide by n. That is your mean. Mean is nothing but the arithmetic average. So for example, if you have the data 20, 30, and 40, the mean of this would be, obviously we all know it's 20 plus 30 plus 40 divided by the number of observations is 3, which is 30. So 30 is the mean. So mean is the average. And what about median? Median is also a measure which is used for understanding the center of your data. So how do you know what is the mean? Mean is, how do you know what is the median value? Median value is the middle value or the center value in an ordered sequence of observations. Remember, we are using the So given some data, we have to arrange it in a sorted order, ascending order, and we have to pick the middle value. Suppose your data is 9, 3, 6, 7, 5. The middle value, if you arrange it in ascending order, it will be 3, 5, 6, 7, 9. The middle value is 6. So that is the median. So in short, median is the middle value. Suppose you have an even number of observations, the middle value or the median value will be the average of the two middle values. So this is a measure of the center. And similarly, there's also one more thing which is called mode. Mode is actually defined as the value that is observed most frequently. In a given data set, when a particular value occurs often, the one which occurs most often, that is what is picked up as the mode. Sometimes when there is no repetition of any data, then in that case, the mode is undefined for that data set. So these are all measures for central tendency. So if you go back to this, so we have covered what are the measures of frequency and what are the measures of central tendency. Next, we have the measures of dispersion or variation. So before we go for dispersion, we must decide on whether to use mean or median for our experiments. So it is dependent on what research question you are trying to answer and what variable you are trying to analyze. Suppose you take the case of variables like family income. So if you try to collect a sample from 1,000 people and you're trying to understand or infer something about family income, somebody may get a very low salary, somebody may get a very high salary, and so on. So there, if you try to take the mean and try to say that this is the central value, that may not be a good response, because when somebody has got a very high salary and somebody has got an extremely low salary, the average value will not be a true measure of the central tendency. So in that case, you have to pick up what is called as the median, which is the central value, wherein you arrange all your variable values in ascending order and you pick the central value. So median is actually, the inference that we are trying to make here is median is less sensitive to outliers and it gives a better measure than the mean, that too particularly for highly skewed distributions. Right. Coming to variability measurement, how do we understand the variance? So you have measures like variance, standard deviation, interquartile range, coefficient of variation, etc. What is range? Range is actually not a true variability measurement. It's a bit raw. Still, that is also considered as a measure in some cases. When you have data like 10, 5, 2, and 100, the range that you have is the highest maximum value you have in this data set is 100. The minimum value you have is 2. So the range is 100 minus 2, which is 98. So the difference between the largest and smallest observation is the range. Right. Then coming to variance. Variance and standard deviation are widely used variability measures. How do you find the variance? You have a formula. For finding the variance, first you must calculate the mean, and then each instance or each observation, how far it is from your mean. So just find out the first day observation x1 minus the mean, the whole square, plus etc. up to the nth observation minus the mean, the whole square, divided by n minus 1. So this is what is called as variance. And if you take the square root of this variance, that is where you will get standard deviation. So variance and standard deviation are widely accepted measures of variability because they will give you a good idea about how each individual data point is away from the central value. The central value is nothing but the mean value. How much distance apart the mean value and the individual data points are, that you can understand from variance and distribution. Coming to quartiles, quartiles are also considered to be good measures of variability, wherein given a data set with some n number of samples, we can find out what is the first quartile, denoted by Q1, which corresponds to the first 25% of the data. The second quartile, which is between the 25th and 50th percentage points, and the third quartile is the 25% of the data lying between the median and the 75% cutoff point in the data. So these three quartiles, Q1, Q2, and Q3, will tell us the knowledge about the range of observed values when they are cut into portions. So Q1, it is the measure which corresponds to the first 25%. This calculation, how do we find this? This is done by using n plus 1 divided by 4. Qth observation of the data. So we can find the first quartile, second quartile, and third quartile. So this is also considered to be a measure for variability. Right. And one example is given here. You have some data set here, 3, 6, 7, 11, some data set is there. Totally there are 15 observations. And you can apply this formula, n plus 1 divided by 4, followed by which quartile, Q1, Q2, and Q3. So you apply that and you will get Q1, the first quartile, the data corresponding to Q1 will be 11, and data corresponding to Q2 will be 40, and the data corresponding to Q3 will be 61. So first quartile is at 11, second quartile is at 40, and third quartile is at 61. And you can find out the difference between Q3 and Q1, which is called the interquartile range. So in this example, 61 minus 11, that difference is what you will call it as interquartile range. You can find the difference. So these are all some measures for variability. The last measure, which is sometimes used in some kind of research, is shape measurement, wherein we would like to know about the symmetry of the data, whether there is any symmetry or there is no symmetry. That you can understand by using this measure called skewness, for which the formula is given. And given data, you can find out the mean, and then you can calculate the skewness, and you can find out whether your data is right skewed or left skewed. So to understand about the distribution of your data, you can use this shape of the distribution. You can understand from skewness. And you can also understand from the kurtosis also. Kurtosis will measure the peakness of the distribution of your data. How, whether you have a narrow peak and so on, that you can understand from the kurtosis measure. So these are shape measures. So to summarize, what we have seen in descriptive statistics is, we have seen the measures of frequency, measures of central tendency, measures of dispersion or variation, and the measures of shape. So from this, what we try to conclude is, given a data set, you can subject it to this descriptive statistics analysis, and you can make some inferences out of it. So for example, to summarize all this discussion that we have made, I have not shown you the data set here, but I have assumed that I have taken the COVID-19 data set collected for a period ranging from February to June 2020 in New Zealand. And from that, we have done simple descriptive statistics data analysis, and the values are tabulated here. So we have three categories: new test, new case, and new death. In other words, what we are trying to do is how many tests are done and how many cases, new cases have arrived, and how many deaths. So this totally, we have 156 days of duration, that is from February to June. That period is taken into account for all this calculation. So from this data set, you can do all the basic things, like you can do mean calculation, frequency count, you can measure the variance, etc. And some of the key things are tabulated, like minimum value, maximum value, mean, standard deviation. So what we have tabulated here in this table, these are all the descriptive statistics measures that we have collected using the simple statistics formula that we have seen till now. So from this, if you have to make some inferences, some of the inferences I've written here, just one we will go through. Taking a look at the first row in this table, new test. So from this, what we understand is the average test, number of tests per day for COVID-19 data set taken in New Zealand for a particular period is 1857. Because what is this average? It is calculated from mean. So it is 1857.88. So we can just make it a whole number and call it as 1857. So that is the average number of tests conducted per day. And the maximum capability of testing in a particular day is 7812, and the minimum is 0. And the daily test has a large variation in the last 5 months. Why large variation? Because the measure of variability is standard deviation, which gives a huge number, 2260.977. So from this, we understand in the last 156 days period taken into consideration, there's a large variation. So this is how we make inferences from the descriptive statistics that we have calculated. So as part of data analysis, we have used the descriptive statistics measures, and we have analyzed the data, and we have drawn some inferences out of it. So like this, to draw meaningful inferences from the data, we systematically go about doing this descriptive statistics analysis, right? Okay. And you can also plot it in the form of a graph. So one graph has been plotted here to show, from the graph, you can just make some inferences again. So the period in which you had the most number of cases and you had the least number of deaths. So the number of cases and the number of deaths are given in the form of a graph here. So from this, you understand that the period between March and May was the peak period where you had the maximum number of cases. And looking at the number of death cases, the curve is so small that you can't really make out, which means that the number of deaths was so very small. It was almost like close to zero only. Very few rare deaths happened in that period. So those are some of the inferences that we can make out from the descriptive statistics that we have collected so far. Now moving forward, whatever data we have collected, the simplest way that we have presented it to the user is in the form of a table here and in the form of a simple graph here. But there are a lot of nice graphical methods, graphical tools available to help you present the results of your data analysis in a nice way which the users can understand. So that is where you have bar diagram, pie chart, histogram, box plot, all these, which will help you, pictorially view, because a picture is more easy to understand than reading pages and pages of text. So whatever analysis, statistical analysis you have done, you can easily present it in the form of diagrams. So some commonly used diagrammatic tools, graphical representation that you are following to present your results is one of which is bar diagram. Bar diagram, as you know, it is used to list the various categories, and by looking at the bar diagram, you can understand the count of the number of samples which fall in each category. For example, we have used this table, data in this table, where there are 3 treatment groups and the frequency in each group, the count or the number of persons in each group, that's given here in the table. So this data we can present it in the form of a graph. This graph is what we call it as a bar chart, which is used to present the frequency of the various categories. So for example, in treatment group 1, that is category 1, how many people are there? 15 people are there in group 1. Then in group 2, we have 25 people. In group 3, we have 20 people. Altogether, we have 60. So this is presented in the form of a bar chart. Then next, we have pie chart. Pie chart also presents the same detail, but in the form of a circular pie diagram, wherein each slice in the pie will correspond to one category. So category 1, 25%, category 2, 42%, category 3, 33%. So this is another way of putting your results. Then you have the histogram. Histogram is used to present your results in the form of a bar diagram like appearance, but then from this histogram you can understand the shape, center and spread of your distribution. Like the moment you have the histogram in hand, from this itself you can understand the shape of your distribution and what is the center of your distribution and so on. So for example, corresponding to the descriptive statistics in the right side of the slide, the histogram in the left side of the slide presents the summary statistics. So all that what you see there, you can see most of it here in a diagrammatic form, from which you can understand the shape of the distribution, center and spread of the distribution. You have another nice graphical notation used to denote the 5-number summary, which is the box plot, where the quartile calculations, Q1, Q2, Q3 and median calculation, all that we have seen, that can be presented in the form of a box plot like this. So here you can understand everything about the median value, minimum value, maximum value, Q1 cutoff point and Q3 cutoff points. All this you can understand. Then all the way we have been discussing about descriptive statistics. Quickly, we will go through the inferential statistics. Inferential statistics, as I said, is used to make generalized things. For example, if you take descriptive statistics, you have been only concentrating on a small sample, from which if you want to extend it to a large population, that is where you will use inferential statistics. So we will collect data from a sample group of people or a group of respondents. You will collect the sample and you will calculate the mean, distribution, standard deviation, etc. All that you will do, from which when you want to extend it to a larger population, you can estimate the parameters of the larger population. In other words, you can estimate the population for the mean, the mean for the population from the mean that you have calculated for the small sample. That is what is called as estimating the parameters. So having known the mean for a small sample, we can extend it for finding the mean for the large population. Then we can do what is called as hypothesis testing, where you, as part of finding answers for your research questions, you will formulate your hypothesis, which has to be tested. So for conducting the hypothesis testing, you will take the help of inferential statistics. For example, you can take a hypothesis statement like this: if the multivitamin capsules help children to perform better at games, you can formulate this as a hypothesis. You can try to conduct experiments, collect data, and you make some inferences out of it, for which you have hypothesis testing methods. So where you have 3 kinds of test methods: comparison test, correlation test, and regression test. Comparison test is when you have to compare the means of some groups. When you have exactly 2 groups, then you will go for t-test. When you have more number of groups, then you will go for ANOVA test. So when you want to compare the mean of 2 groups, then you will conduct a t-test as a comparison test. When you have more than 2 groups, then you will conduct ANOVA test. Then correlation test is conducted in order to understand the relationship, correlation or the relationship between variables. So for which you have Pearson's R correlation coefficients, Spearman's R correlation coefficient, and chi-square test done. So these are all correlation tests which are conducted in order to understand the relationship between variables. Then you have regression tests. Regression tests are mainly meant for prediction purpose, where you try to understand the relationship between the variables and use that for predicting the outcome of an experiment. The techniques you have in this category are simple linear regression, multiple linear regression, and logistic regression. And I've briefly explained all these to you. So we will straight away go to the tools that you have for data analysis. You have several tools which can help you do both statistical, basic descriptive statistical analysis or inferential statistical analysis. The most popular ones which are used by academic and industry people for research are these: Microsoft Excel, Statistical Analysis System SAS, Statistics Package for Social Science SPSS, MATLAB. And other than this, you also have some new programming tools like R and Python, which have a lot of libraries available which support the calculation of all these descriptive and inferential statistics. And for presenting your results in a nice format, you have Tableau and Microsoft Power BI, where you can do analysis and present it in the form of nice charts and graphs. All the tools that you have that I've listed here in the slide are all supporting a lot of quantitative research. When you are more worried about how to present it when you're doing qualitative research, these tools can help you, like NVivo, Atlas.ti, Provalis Research, MaxQDA, RQDA, Quirkos, Qualcoder, Quicka, Aquad. All these are tools which will help you in doing data analysis in a qualitative research environment. Then coming to what are the challenges and issues that you have in data analysis. As we know, when you want to do data analysis, you must have sufficient math and statistical knowledge. That is what I mean by the necessary skills. Without a good knowledge of math and statistics, you can't do data analysis. Simply, you have a tool, you use the tool, and you just give your data, and the tool will give some result. Then that is not going to help, because to do data analysis, you need to possess the necessary math and statistics skills. Then only you can do good analysis and do good interpretation out of it. And data analysis is dependent on proper data collection. Unless your data collection is perfect, then your analysis will not be okay. So you have to do good, spend good amount of time in proper data collection, and then you have to choose good data analysis and do data analysis. Then, when you have a lot of collection of data, you may have to do subgrouping. When you do incorrect subgrouping or inappropriate subgrouping, that will lead to wrong analysis. Then when there is some kind of mistakes in your analysis, there is a chance of leading to biased outputs or biased outcomes, which is not desirable. Always it is required to make unbiased inferences out of your data analysis. Then what is working in one discipline, or say, for example, what technique works good for social sciences may not work good for physical sciences or biological sciences. So whatever norms are set for different disciplines, each particular norm for each particular discipline must be strictly followed. Then you have to understand the statistical significance and set it when you do this data analysis. Unless you have very well laid out clear outcome measurements, then you can't do proper analysis at all. Then you have to do accurate and honest analysis without any bias. And you must decide on the good set of presentation tools, like which chart is appropriate for presenting which data analysis result that's required. And having collected data, you must record the data in an unambiguous manner, which many times does not happen, leading to wrong analysis. And when it comes to analyzing text data, partitioning the text in an easy manner such that you can do proper qualitative data analysis is posing a lot of challenges. And every experiment that you conduct must be reproducible so that you get the same kind of result each time. So reliability and validity are important things to be taken into account, but which are posing a lot of challenge in data analysis. And the extent to which you must analyze, how long and how much to analyze, that's also a challenge. That has to be decided by the researcher, of course. And finally, to conclude this entire presentation on data analysis, though this data analysis is very much well known to all of us, But how much strictly we are practicing all this? That is what is the question. Which technique, where we are applying, why we are applying, with a thorough knowledge, if you apply, then we will end up with good success. So it depends on what data was gathered and how successfully we are applying the various techniques. And understanding the assumptions and capabilities of the different methods, which method will be suitable where to do t-test, where to do ANOVA, that has to be carefully chosen. And the presentations of the findings must be present in order to support the argument that you placed. It should not overstate the evidences that you've got. Yes. And finally, to conclude, what data you have collected, and from that, what analysis you have done, does it paint the accurate picture? This is what you should make sure, right? And many thanks for listening to my lecture. And once again, I thank the organizers for giving me this opportunity.
Thank you, ma'am. Dear participants, if you have any queries, kindly post to chat box. Dear participants, if you have any queries, kindly post in the chat box. The platform is for you.
Thanks, participants. Thanks for your listening. I made it as an introductory kind of lecture because I was told it was a heterogeneous audience of different groups of people at different knowledge levels. So this was done. And you have like on the internet, so you can just download and go forward from here.
Ma'am, good afternoon, ma'am.
Yeah.
Ma'am, I have a question, ma'am.
Yes, please.
Ma'am, suppose if you're going to use the data sets for cancer or lymphocytes, that is cancer for the children's, I think which will be better, ma'am, whether to use the data mining or the data science, ma'am?
In between, your voice was interrupted. Whether to use which data?
Ma'am, suppose if it is a cancer data.
Okay.
Those kinds of data sites, whether if you're going to use the data mining techniques or the data science, which will give the better results, ma'am?
Okay.
Or any kinds of medical data
are
sets.
Very much interrelated stuff. Okay, okay, no problem. You take any data, numeric data means whether you are using data science or data mining. Actually there is these two are totally intertwined only. You can't just say them as two separate things. See, what we are seeing in the name of data science is all algorithms, which again are in data mining also. So what we have is basically all this data science, data mining, everything will take its roots from statistics only. All the new algorithms that have been designed statistics only. Basically, it's all from this, what do you call this, mean, median, variance, ANOVA test, t-test, all this only. So depending on what your application is, what data you have. For example, if you want to use data mining algorithm, generally it all depends on the application. Typically, data mining algorithms are used in recommendation systems, those kind of applications. What I mean by recommendation system is when you're browsing the internet and you want to buy some products or you want to watch some movies, automatically a data mining algorithm will come up with some suggestions for you. So that is where your data mining algorithms come into picture, and those data mining algorithms trace their route to statistics only. And when it comes to data science, what is taught in data science or what is practiced in data science is also the same kind of statistics only, where we try to do pre-processing, do some basic descriptive statistics or t-test, ANOVA, all this correlation, same stuff we do. Where for what kind of problems you will apply it is, for example, typically you take, you want to find out whether taking a particular medicine will help in treating cancer. For that, you will have data where collect your data, then form your research hypothesis, then do this basic data science and statistics kind of treatment. So this, wherein you will either reject your hypothesis or accept the hypothesis depending on what answer you are getting. Test or ANOVA, all this you do. You have experimental group, control group, all that you form and you create. You do the accepting the hypothesis or rejecting a hypothesis. That is all completely related to basic statistics, which is what is the main component of data science, right? So depending on what application you are trying to do and what kind of data you question that you're trying to address, from there only it comes. Data mining is more, used there in places like recommendation systems. When you buy this product, the system recommends you with other similar products and so on, for movie recommendations. For this kind of stuff, mainly data mining algorithms are used, and depending on the even in Google, when you type some words, it automatically comes up with the next word suggestion and so on. For all that, you make use of data mining, again, which in turn takes the help of statistics only.
Yes, ma'am. Thank you so much, ma'am. It was really a clear-cut differentiation between whether to use a data mining or a data science, ma'am. I got a clear idea, ma'am. Thank you so much, ma'am.
Thank you. Thank you. I'm happy.
Participants, any more queries? The forum is open to you. Ma'am, I think there is no more queries, ma'am. Thank you so much, ma'am. It was really an interactive session, and we got so much knowledge regarding the data science, ma'am. Thank you so much, ma'am.
I'm happy. Thanks to the organizers for giving me this opportunity. Thank you. Have a good day.
Thank you, ma'am. Participants' feedback is posted in the chat box. Kindly fill it. Thank you, Sikapi, ma'am.
Thank you. I'll end the session. Thank you.
Yes, ma'am.